Hello, my name is Michał Niczyporuk, and welcome to my talk, Beginner's Guide to Observability. A little bit about myself. At the moment, I'm a software samurai at Merxu. It's much cooler title than the official one in HR, which is Senior Front-End Developer. So that's why I chose this one. I used to be a team lead consultant, a solution architect. I had 15 years of experience in various fields, in various economic sectors. And I'm a leader of WJUG for the last 10 years, a little bit retired at the moment. I would like to set expectation for this talk. So this is not a deep dive. This is an introduction to the topic. I hope even some senior people I can see will learn something from this talk. So agenda, we'll be talking a bit about observability. Then we go to the logs, the metrics, tracing. I will talk a bit about APMs, and we will finish up with events, which is the newest and latest solution that we have in that space. Well, what is observability? Well, Americanized O11Y. The definition from Wikipedia is quite dull because it says that observability is a measure how well internal states of the system can be inferred from the external outputs. But it's 2024, we are on the hype of AI, so we have to ask the ChatGPT the same question and gives us exactly the same answer, just more verbose and not really my style. I prefer the Wikipedia one. What do we need observability for? So we need it to determine the state of our system, if it's working, if it's doing the job that we gave it, okay, if it's failing and so on. To observe trends, so we can know that in the future we might have to buy new hardware, pay more for our cloud bills and so on. Spot anomalies, so basically see that behavior that is not the way it's supposed to be, so slow requests, and so on. Help up debug errors in production, because systems are complex and sometimes we don't know what our change can affect. And gather data to support any decision processes. So basically, if the company has to invest in some way, put some money, it's very tied to the observed trends, but basically giving data to our bosses is better than giving our instinct and gut feeling. The hard data is always better than that. And the last but not least, measure user experience. So we can say that the users who are using our systems have a good and good experience using them and are happy using those systems. For the first, I will start with logging. It will be a fast, but I know that everyone logs and everyone did it one way or another in the system. This is basically rule number one: we don't use system out println. Never. Unless for debugging, but never. We have to pick up logging library. At the moment, it's log4j 2.0. Use 2.0 because it's much better than the 1.0. It's faster, or logback. Then we select the logging facades. So we have SLF4j, and since Java JDK 9, we have platform logging API, which is also the facade for logging. It doesn't implement it. It's only like an API that logging libraries can implement and use it. So your code wouldn't have any compile time dependency on the library itself. You will be only depending on the Java. And we can also use so-called bridge libraries, like for Java util logging to SLF4j or Jakarta commands logging to SLF4j. I know this is a bit confusing, so I have this slide. As you can see, basically, the facades is what we are using in the middle in our code. The binders, providers on the right, this is what we will be doing in the actual logging. As you can see, in the top one you have log4j and logback. But at the bottom, you have also Java user logging and Apache, Jakarta common logging, which are old technologies. So basically, SLF4J thought that sometimes you need to deploy to JBoss or something else, and you have to log to something that is basically a legacy at this point. So they allow you to redirect any kind of logging statements from SLF4J to those old and deprecated at this point libraries. And the same can be done from the other side, because SLF4J can capture any logging statements made from those legacy logging libraries using bridges. So basically, that any code, like if you have an old library that has not been updated in many years, but it's used Java utility logging, and you would like to have logs from that library in your code, you can install the bridge from SLF4J, and it will capture every single login statement and redirect it to whatever SLF4J is capturing. And the fun fact at the bottom, as you can see, the facades can point to itself, because in this example, SLF4J has also a small bridge that basically implements system logger. So if you use a system logger, it will SLF4J can capture any kind of traffic and redirect it to the binders and providers that are on the runtime. Is that clear? Now, so how do we use logger? We define usually in Java static final field. We have my method, migrate code, method X, logger. But sometimes when something doesn't wrong, it's a nice output. And sometimes we have debugging, talking to the void, when we are just asking a compiler to code to run it, and we finally notice that we are running method Y, not method X. And probably facepalm ourselves after a few hours of looking at this code. So, few things about logging that you should do whenever you do it. Log meaningful checkpoints. So inputs to your application when you are changing state of something, and so on. You have to use correct logging levels, because I saw myself where people are using error logging level to log basically a debug information. It's good when you are logging to add IDs, any kind of IDs to logging context. So you can basically connect the log statements together in your log files. They so-called even correlation IDs, so they can correlate the lines from the same requests and so on. User IDs, and whenever you are doing alerting in your system, don't do them on logs, prefer metrics, because logs are very they're not well defined. Anything can trigger your alert if you don't look at it. So metrics are much better for alerting than logs. And whenever you have a high throughput application, always use async login appenders. So you are not waiting for the log to be written down to the file, to the log file, because it will be basically faster. And whenever you have a reactive application, this is like you need to have it. The do nots. You laugh at this. Good. Assume that logs can be lost. You will not ever have every single log that you made. They can be lost and never count on them. So never treat them as an audit trail. If you need to audit something, you have to design it, because you're probably reporting to some kind of either in company or outside to some kind of government agency, and basically do not count on them. Do not treat them as metrics, because I've seen that you can do some kind of ad hoc calculations on logs, but do not treat them like metrics, because metrics will be much faster and more efficient than doing that than, like, for example, counting the amount of requests that you are getting in your system. Don't do that. And do not treat your logs as data warehouse, data lake, basically, and data analytics platform, because you will be spending a lot of money for the solution that shouldn't be basically in your area. There should be a separate data warehouse. I've seen 3 times this done already, so be wary, because you'll do a little slice log, dashboard, business will start using it, and then the business is dependent on that dashboard, and you are not able to basically deprecate this storage, this solution that you made ad hoc. About stuff that you are supposed to be logging, Piotr Przybył, basically when he was hired at Elastic, treated this. So the stuff that you don't want to log is PII, so personally identifiable information, names, surnames, social number, parcel in Poland, secrets, sessions, tokens, etc. No, you don't want to. I worked at a company that we had the list, and sometimes something would leak, so usually from the Jackson errors, they were not very happy security people, because we had to go through the Splunk and remove every single line. So now they say that you can do, I think they say that you can hash stuff before you log them. So that's fine, right? But not like logging in plain. Okay. Since we are living in distributed world at the moment, we have microservices and so on. Having one single log on one single machine will be so 10 maybe, something, maybe even in 20,000s. We need to centralize our logging. So to start centralizing our logging, we need to have a similar structure. We need to have uniform format. It's either will be JSON, logfmt, or OTLP. We'll be talking a bit later. And do not use regex for parsing your logs, because you will have 2 problems. The very classic problem: do not use regex to solve your problem. We need the central storage. This is basically Elastic. It's a Kibana. It's a classic that you have that lives in that space. So we need to. We will be sending our logs to that software. It will allow us to search those logs, aggregate them, do some kind of operations to make our job with those logs much easier. We need to publish those logs. So as you can see, we have basically 2 modes of operation. We can push those logs directly from our application. We'll be pushing them to the central storage. We can push with local agents that in Kubernetes that would be working, for example, on your Kubernetes node, you would have a running daemon set, and that daemon set would be forwarding the logs to the central storage. And with the pull model, so that's also very nice. You have also daemon set, like an agent on your node that would be reading logs from your application, or from console, or from log file, and pushing that to central storage. The difference here is basically amount of coupling to infrastructure, because as you can see in the push model, we would have to send the information like node that we are on, data center we are on, and with local agent, that will be the job of the local collector, and the same with pull. So basically the pull gives the least amount of coupling to the infrastructure, and I think it's most desired that we would like, because we don't have to, if something changes in the infrastructure, logging infrastructure, we don't really care. It doesn't affect us that much. And here is the road rule of the thumb. So basically, more traffic you have, you will have more logs. This is like the universal. You more traffic, you're logging more, because logging every single request that you're getting. This is something that you have to remember. Of course, the sky is not the limit. The limit would be probably some team that you're running your logs, or your cloud provider. And the tooling in the space, you have the Elastic. It's like Elastic Stack, ELK, so Elastic Search, Logstash. Now Fabric, yes. Kibana, Greylog, Grafana Loki. In cloud providers, AWS has CloudWatch logs, Azure has monitor logs, and Google has Cloud Log. Next on to metrics. So metrics are numbers indexed over time and couple additional dimensions. So they're basically a time series. All metrics databases are time series databases. They're optimized about storing the numbers as time series. To store, we need some kind of storage. Here we have the basic UI of Prometheus. Looks pretty simple, but usually I use Grafana personally. You can use something else that you have. We need to push those metrics. This is the same thing as is with logs. We either push the logs to the central storage, to the local collector, so Kubernetes would be that per node, for example, or per the virtual machine that you have. And in pull mode, basically you are giving an endpoint that provides logs in certain format. This is how Prometheus operates. So basically you just give the endpoint and you don't care. Your everything is on the infra. And the same thing is with coupling. Basically the pull model is the lowest coupling, and I think it's the most desirable that we can get. Metrics have types. This will be the ones that are in Prometheus. They're the same depending in each vendor, so there are similarities all around. So the first basic metric is counter. It's basically a monotonic counter that grows. It's not useful as itself. Like we see this. That's, for example, when you're using Grafana is wise and will tell you, hey, you can calculate the rate of this counter by adding rate function. And you click it and it will automatically do this method. So it's much more readable. As you can see, basically, it will calculate the amount of increase of the counter in periods of time. Usually it's used, and we use it mostly basically for counting anything. So errors, requests, jobs count, Kafka messages, whatever. Gauge. So gauges are interesting because they can go up and down. They are not monotonic as counters. And usually we use them that we have pools of something. So we have memory, thread connections, pool connections, stuff that can go up and down, or for example, active amount of connections. And my tip for gauges to store current and maximum values, not the percentages, because in long time you might want to know what was the configurations, especially if someone changed something ad hoc in configuration without committing it to the repository, for example. The next one is histogram. This one is used for latencies. Basically, it splits the metric into the buckets. So it will just count amount of each example. For example, requests in each bucket. It looks like, as you can see, basically a numbers growing a little, and so on. But as the same, Grafana is nicer, and it allows us to calculate a quantile, so basically a percentile from those data, from those buckets. And my pro tip here is to use pre-configured buckets in your application, because the automatic one is usually too granular. There are too much of them, and they put a lot of strain on the metric storage system, and helps you a lot faster, basically, and you'll be able to store much more data in much more longer period of time than relying on the automated bucket sizes. Oh, as you can see this. Summary is basically histograms, but the percentages are already pre-calculated, and So you will just provide that this metric with those parameters at this percentile is that amount. They put a lot less strain on the metric storage systems, so they might be more desirable by the people that run those storage systems for metrics. The next important thing is metric attributes. The main dimension is metric resolution. So this is how often do we probe those metrics. If you want to store them long term, you will either, it's called the same, but it's downsampling or rolling up. So basically, after some period of time, let's say that we are storing 1 minute of resolution for metrics up to 7 days, and after 7 days we store resolution of 10 minutes. So basically, those 10 samples that were every minute are rolled up into the sample that is every 10 minutes. And it's pretty good when you have business cycles in your business, because then you can just look, for example, a year back. Oh, at Black Friday last year, we had this amount of traffic, but this year we already have the increase of, for example, 20. So we need to up our infrastructure budget by those 20% for Black Friday. So we won't be hit with any kind of outage. And your mileage may vary. Basically, it's how do you work? At the moment, I have like only 3 days of storage. I don't need more. I don't have cycles, so I'm safe there. And another important thing is metric tags or labels called differently. This is additional maintenance. This is all the metadata. So HTTP attributes like methods, endpoints, name of our Kubernetes pod, Kubernetes service, host that they're running, cloud regions, and so on. This is all can be metadata. But in metrics, the labels don't like cardinality. So we have to watch out. We're supposed to be using, like, we want to have a root. We want to have the generic one. We don't want the one with the ID in each metric, because Prometheus probably will die pretty fast. Been there, done that. What to measure? The next thing is important, so you know what types of metrics we have, what we are supposed to be measuring. There is a model by Kik Pepperdine. He basically runs, he's like a god of performance in Java, but basically one of the most known Java performance guys. He has a model. This is the link to his model. And your libraries will cover basis already, so you don't have to think. The model is like this, basically. We measure people, incoming requests, messages, jobs. So basically the amount of job we are doing, like we want to count. We measure our application. So Netty, Tomcat, Spring. We measure thread pools, queue sizes, connection pools, the amount of requests coming, the latency of those requests, because you might have a difference between what you have between. We measure runtime metrics, so that will be the JVM. We measure the garbage collection, how much memory we're using, how many threads are running, and what state there are, and so on. And last thing, we measure the hardware. So how much CPU we are using, how much memory, how much I/O, how much disk space we are using, and so on. Since we know how to measure, what to measure, now we have to know we are supposed to be measuring it. So the Google Site Reliability Engineering book, so this is like the SRE book that you probably meet, says that there are 4 golden signals. So the latency, so how long do we take to serve the requests, how much traffic we are getting, so how many requests are hitting us, how many errors we have, how much of this traffic is errors, so we return 500s, 400s, and so on. And saturation, so this is what our capacity, how much over capacity we are. So we know that we are, for example, starting to queue requests and so on, that the connection pools are getting full and so on. And they split it into like two measure methods, RED and USE. The RED stands for rate error duration. So we have a rate of incoming traffic. We think about how many errors do we return and how long do we take to serve this traffic that is coming. It's more focused on applications. So for developers, it's more important. And the second one is USE. We measure utilization, saturation, so how much overcapacity we are, and how many errors do we get. And this one is more infrastructure focused because we can measure how much CPU we are using, how much memory we are using, and, for example, errors from the system that we are getting. But sometimes people want simple solutions, and sometimes they want one metric to rule them all. There is such metrics. It's called updates. It's not a metric, it's a methodology of calculating that metric. They have like an updates alliance that is comprised of observability vendors. And it's more focused on the measuring the user experience, not like technical stuff. It uses the technical data, but it's more about measuring the satisfaction of the user. And it's a single number, so it's very general. And I will die. So how do we calculate an updex? We need to have at least sample size of 100 requests, for example, for application. And we have to focus usually on one of the functionalities of the applications. And we have to split the population that we have to three areas. Satisfied to T. So that would be the time is, for example, it will be latency. It will be T, where the user is satisfied with the application. It's happy. The application works nicely. It's very fast, responsive, and so on. The next population is people that's tolerating. They are noticing that the application is slow, but they are still bearing with it. And that population goes from T to 40. Because apparently the 40 is something that they researched and got it. The 40 is this nice. It's a nice solution. We have some research that we can back it up. So I didn't really look at it into. And the last one is basically everything besides 40. So people that basically close the tab already because they were frustrated with our application, with the responsiveness, the experience that it gave. And the sample size of 100. So we have to have like 100 requests, for example. The step 2 here is basically very easy because we just take amount of satisfied people, so requests in our example, and we add it to the amount of tolerating requests divided by 2, and then divide everything by total count of requests in the given window. And this will give us a number between 0 and 1. Pretty simple. And step 3, we have to interpret the result. The general rule is basically if you are dropping, you're supposed to be between fair and good. If you are dropping to poor, you are basically in the danger territory and you shouldn't be dropping into the acceptable range. So below 0.49, because that means that you are getting, most of the people are in frustrated and tolerating area, and you don't really want that. We personally are using this for our search, so we are measuring our how long it takes to return search results to users on our site. And usually we do stay in the good area. So, and this allows my company basically to keep the eye when we're changing the messing with Elasticsearch a lot. The caveat here, this is generic metric. It's only one number. It will hide details. It will only give you like maybe a feel what's happening. You have to have additional data to measure how the customers will react. And you have to monitor when you change something because you might affect it. If it goes down quite fast, you probably have to undo your deployment if you're able to. And you're supposed to be able to undo your deployments. And do not count it as the only metric of application success, because there are other data that you will be supposed to be laying. This is just one very generic metric that will hide a lot of details. Okay, I was talking easier about the percentiles. I have a question. How does the distribution of latency looks like? Usually. It's more polynomial, so basically Scala developers would love it because they love to solve polynomials in their business code, apparently. So this is, it's quite big. I think it was like 1 second. So as you can see, it's not very uniform. So that's why we are supposed to be using high percentiles, because as you can see, you're not able to, you'll never be able to cover the 50%. You have the other half at least, or even, well, you have the other half, but it's not uniformly distributed along the axis. So always use high percentage, 95, 99, the best. Who can tell me what's happening here? We have a client who sees the P99 of 1 second, and you have server that he sees a P99 of 100 milliseconds. What? No, not hardware. It's a general issue, maybe. Yes. It's called coordinated commission. So basically, the services count servers. The server counts the P99 at this boundary, right? But it doesn't count the wait times that can happen before it in those two places. So that's why server serves everything nice. It's 100 milliseconds, but the client is 1 second. So you're able to do, always measure both clients and servers, so you won't have that problem. It rarely happens, but when it happens, it can be quite puzzling what's happening. Usually there is some queuing as connection pools are exhausted, thread pools are exhausted, etc. And beware when you're storing metrics, do not store a lot of them. Really pick what you need. Because so I love Spring Boot, but basically if you add a few starters that you need, you have a lot of metrics that you don't need usually. And it is the same about the dimensions of those metrics, that you have to figure out how many dimensions you really need. So this amount of metrics will basically bad for your infrastructure cloud builds because you have to pay to store them. And it will be bad for your mental health because you won't be able to figure out what do you need when you really need it. So always try to start with some starter metrics and basically drop everything else you don't need. And I have two assumptions that I have to correct because I always meet with people. The first assumptions is the same as logs, so the metrics can be lost. They can be lost because they are made to be fast. They are not captured very reliably. The capture has to be fast and so on. So they can be lost. You can have dropped data, and that they can be. And from the fact that they can be lost, they are not precise. So this assumption that the metrics are precise is never true, because they are even made. The calculation of those metrics is made so that we can have some very fast, so they are not doing like big decimals. They're probably adding just 2 floats to make it faster. And who can tell me how will be the amount of logs be growing with traffic. I can give one. It's stable. It will be stable. Well, it's one caveat when you have the same infrastructure, because you add one new server, so technically you add one new value to the metadata, for example, but generally this is stable. Basically, more traffic, you have the same amount of metrics, just higher numbers of those metrics. I will have some little examples. So as you can see, this was metrics of the request counts we were processing. I think we were reindexing some data, some Elasticsearch query, Elasticsearch index, and we noticed that we had a missing index. It was there. It was just not used. So we had to drop it, recreate it in the same time, and suddenly we grow 10 times in speed, and we were able to do something that was going forward. And over an hour in about 7 minutes. So this is why you need metrics, so you can see that something is behaving very, very, very weirdly. And another example, basically our database decides to have a sabbatical, so took a load of, I don't know how much, but I think the last number we had was 40. So we had to reboot the whole virtual machine and let the cluster basically go back to full health after rebooting the main node. We still don't know what happened. That's how that happens, but we are able to fix it, and we are alerted by the alert on those. The tooling here, the classic, the Prometheus plus Grafana. There is Victoria Metrics, which is trying to be the new, better, more faster, more agile Prometheus. We have Elastic Stack, which has already is already growing, trying to grow past logs and past full text search. Whatever comes with your cloud provider, Google, there is a Google, basically a Google Metrics, Cloud Metrics service. We have libraries for metrics. So we have Micrometer, which is adopted by many different services in Spring Boot. I think Vertex uses it. And we have also OpenTelemetry, which is an open vendor-neutral observability library. I will be talking a bit about it later. And the last one of 3 is distributed tracing. Tracing allows us to basically to follow the life of our request into the system. As you can see, we get a request, then we trace it from service to service, even to databases and back, even to key value databases and back, and then we return it. And we can see basically how this stuff happens in our system. It is a very helpful tool when you are working with distributed systems, because it sometimes shows you that something went wrong, that necessarily would look bad on metrics, but they look very wrong on traces. So the anatomy of the trace is simple. Basically, trace is a collection of spans, and span contains, each span contains trace ID, which is randomly generated number, span ID, so we can identify each span in a trace, and parent span if span was created from a different span. So the service gets a request with the trace ID and span ID, and then it will be the span ID will be a parent to a new trace that is created in the second service, for example. And all the metadata you can think. Hard cardinality, basically the tracing doesn't care. Whatever you can put it, besides the PII stuff and so on. So, and tip, you have like a Kurzman tracing. If you put trace and span IDs in your logs, you will be able to correlate the logs with traces, and that can be helpful. Yeah, this is basically, as you can see, from the X, we started trace X, span A on the left side, left top hand side. Then we have span B, which is requests parent span is A, C, B, and so on. You can also trace databases and so on, everything. You can add your own custom spans if you need. For propagating those information, so trace ID, span IDs between system, your application, your code, and your infrastructure, so proxies, service meshes, if you use them, they need to be capable of propagation. When you're using HTTP between your systems, it's done by headers. There is a standard. There are two standards. One is W3 trace context, and the older one is Zipkin B-trees. So we had the same. We need basically some storage. So this is Zipkin. It gives us the nice view, as we can see the bars, how long each span. This is a list. This is one trace. This is a list of spans. This is on the left. This is a data, basically the metadata from each span. So we can click each span and we will have the metadata that were collected when this span was created and sent to the central storage. The only proper and correct way to publish traces is only by push. By pushing them, because we probably will be using a lot of traces, which we will be getting them from endpoints. So the only way to push traces correctly is with either local agent or directly to the central storage. I personally use the local collector, but I will mention that a bit later. As you can think, storing traces for each request that we have in our system, we would have a trace. So we need to find a way to effectively store that. Well, so effectively pick what we don't want to store. There are two ways. It's head sampling and tail sampling. The head sampling is basically we get the first trace with an ID, and we make a random decision to store it or not. So we don't wait for the first trace, for the whole trace or most of it. We just take the first trace and we randomly decide, okay, this trace ID stays, the other trace ID doesn't match, it goes out. It's a random representation of traffic. It will work. Law of large numbers will make it work because statistically you will gather some kind of representation of your traffic that will help you. But I personally prefer tail sampling. So when you collect, you're trying to collect whole trace or most of the trace and make your decision based on the data that is inside each span from the trace. This allows you to custom behavior, and I will be talking more about those custom behaviors that we can get. So we can basically have a truthful-based sampling. So we want to have fixed amount of spans per second, and this basically will be tail sampling because we will be storing some kind of representation of spans or traces per second. It will be basically giving us the steady rate all the time. So we have more traffic, we store less traces percentage-wise, but it's still the same amount of speed. This is usually useful when you have like a quota on your cloud provider monthly and you don't want to overfill it. We can have rule-based tail sampling. So basically, we are storing traces that matches custom policies. So for example, we only want to store each span with errors, slow traces, for example, over 1 second and so on. We want to ignore health checks. We want to ignore stuff that it's not really interesting. It's not an issue by the default. And the most important, it's important, but it's very interesting, dynamic tail sampling. So its aims usually are representing the attributes among that collected traces. So I have an example that I would like to go through. So let's say that we want to have an X amount of all traces, but we want to focus have a representative set of values for attributes, status code, and methods. So let's say that we have a window X, we have dynamic sampling setup. We taught to the sampler that we want to have methods that are status code, that represent the status code and method. So in Windows X, we got 3 samples. We got the distribution of those samples in our window. As you can see, this is like 3 different. In the next one, in the next window, we are getting 3 out of 4, but we get 1 is double. So the samplers thought, oh, I already have the sample for status code 200, so I don't really need this one. I can discard it because it doesn't give me the representation that I'm looking for. So this gives us then dynamically, we are able to get a representation of all the spans and traces from the whole system without relying on some random rules. It will give us the better view of our system because we will have this representation from focusing on different attributes, not just on random ones.
Who is deciding? Who is making this decision? What will be? That's the question. It's a decision on the application level, like decision if this span will be set or pushed, or the product level, this span will be saved.
Basically, how I do this, so I do this by, I send every single trace that I have. I have OpenTelemetry collector I'll be talking. And for me, it's making the decision that you collect some traces and we want to keep that one, this trace, but we want to discard that one. So it's more like the local collector I was showing. So we are pushing to something that's the place that will be making the decision. It's not like application, this is infrastructure. So this will be probably set up by some kind of DevOps or admin that you have, for someone for platform team that will be doing that. And so it's okay?
Yeah, but I would maybe continue this question.
Go ahead.
As far as I know, in this being my committer, that it's possible to set this probing rate or something.
Yes, you can set a sampling rate, and I have it always. I have it on 1. I always send every single request that I have because I would be doing sampling down the road, right? Because I'm not sure if every single Spring Boot services would pick the service the trace in the same way. So I'm doing that I'm doing that basically down the road when I send it.
Going with the strategy like shift left this responsibility.
Yes.
Okay.
Well, yeah. In our case, yeah, shift right. Shift right to the infrastructure.
Yes, shift right.
Shift right. Yeah. So and good. Basically, you want to mix sampling methods. So you mix sampling, the head sampling with tail sampling. So, for example, store percentage of all traces, but traces that matching some custom policies. So the slow traces, the ones with errors, because you want to know what's happening. And the few things that one of the things I noticed especially when you're starting doing the tracing in your system, the first traces sometimes look like this. So you have the first span at the top that did almost 2 seconds, and you have 3 at the spans at the bottom that did like 5 milliseconds each, and it looks like it's something not happening. Usually, it happens that you have a missing instrumentation, so you're calling database, some other service, and so on, or you are doing something that is CPU intensive, or you have basically an issue here like low connection pool or thread pool or whatever. So this is something that you basically have to expect. Add this missing instrumentation. Not this button. Or wrap it with the custom span if you're not able to instrument it by hand. And another issue that you will notice often, so that you will be having missing spans. When you are using the software, basically Zipkin or whatever, it will show you that you are missing the span because there is some parent missing or ID. Yeah, they see the span ID, but they don't see the actual span, right? So tools are smart to detect it, and you basically probably have to increase buffering. And I hate Istio for that because you are not able to do that in Istio. I didn't found it yet. and I have like sometimes when we're running a lot of bad jobs at night, Istio tends to miss spans then, or you just hit your rate limiter. How about the growth of rules? Growth of spans amount of tools? Indeed. Oh, this is what I call the Himalayas of spans. As you can see, it's a fresh one because someone wrote the functionality that was supposed to be used on small part of the database, but we used it to do the basically go through the whole database. As you can see, you have a span that has 30,000 calls to the database because it wasn't planned to do that, but it was quite fast. As you can see, 100 seconds wasn't that bad. And you basically, if you are starting with distributed tracing, you will always have a lot of stuff like that. You will find, oh, we are very ineffective because we are calling database or service per one ID, and we have 1,000 IDs in a list. It's a very, very starting. Well, and the little bonus thing I would like to mention, it's baggages. So baggages are basically propagated key values pairs to the distributed requests. They are adjacent to the distributed tracing, but they are not the same. So basically, it's data you can put in from your code into the baggage, and it will be passed over between the requests. It can be like user account IDs, user IDs, product IDs, origin IPs, and so on. So basically not a PII information again. Data from baggage won't automatically go into spans. For example, Spring Boot has a little, I don't know, it's a basically a little option to take baggage and put the data into span as a metadata. Full gun warning, that will propagate everywhere. So if you're using some outside vendor, watch out. Basically, guards on your border of your systems not to send that data to outside sources. And there is a spec for this, basically a propagation format for distributed context package. You want to put the data like in your code. You want to add the user ID and so on, right? And you would like to pass it as a separate data from the trace ID and span ID. Someone thought of it. I wanted to mention it because like every single piece of distributed tracing mentioned the baggage. If sometimes you're not able, for example, to put the data yourself into the span, and you just put it into the baggage, right? It can go. It can go. In Spring Boot, there is like a switch. It doesn't go by default. Basically, it's not connected. But in Spring Boot, you can set, take the baggage if you get it with the request and just put it into the span that you create, to each span that you create, for example, right, during the request. So tools here, the abstraction APIs, OpenTelemetry for tracing, Micrometer for tracing, storage, visualization, open source ones, Zipkin, Jaeger. I think Google has a stack driver, or had stack driver, they renamed it, and so on. The next thing I would like to talk about are APMs. APMs are they stand for Application Performance Monitoring. So they offer basically your automatic instrumentation. They're like all-in-one solutions to monitor your application. They can do logs, they can do tracing, metrics, and so on. You basically plug in one jar, and it does everything automatically. It will also nicely figure out how your services, how your database are talking to each other, and so on. So you have a very nice view of your system architecture. But there are caveats, as usual. Beware. They can sometimes make very arbitrary decision out of the box. You need to call your account manager, sales guy, whatever, and talk with him to basically change them. Sometimes, I don't know, maybe threaten them. So what I heard with people. And for me, those communication guys are a little bit eye candy. They are more of a sales pitch than useful tool. I mean, you can figure out what talks to each other if you don't know the system, but if you're intimately know with your part of the system, you know what's talks to you, to what. And this is basically a trading customization for already used products. And from my experience, it doesn't work well. We didn't work well when we were using it a few years ago with reactive frameworks, because it basically imparts too much performance cost for us. So basically, caveat emptor, watch out what you buy. APM tools, the Datadog, New Relic, AppDynamics, Dynatrace, Splunk, and many, many more. There are open source ones, but they look nice. I never use them.
Well, sounds fun.
Okay. The Go. What? I never heard of it. But it's a very large space. Sometimes you don't hear about company, and you just hear it, and so the last, well, not that, but almost last two previous, I would like to talk about the telemetry. So OpenTelemetry is like third project from this kind. Basically, it's a vendor-neutral observability framework. So it gives you a lot of tools to basically send logs, traces, traces, metrics from your application to your cloud vendors, or basically like any kind of storage that you want to use. As you can see, it provides a lot of data. There's a lot of components. I would only go through them. I will not go deep into them. So there is specification for all components. You can read it, you can understand it. It's quite nice documentation. So the second thing is protocol. They got a OTLP protocol over GRCP and GTP. It's for logs, metrics, and traces. And it's only searched in push model, so there is no pull model like in, for example, Prometheus. They have semantic conversions, so unifies attributes that you have for metrics, traces, logs. So, for example, that in field traces, in field DB operation, you would always find what operation was executed on the database. So you don't have to look, for example, PostgreSQL operation or Mongo operation, Redis operation. DB operation, always that field everywhere. They provide APIs and SDKs, so you can basically integrate with them, use them as in your code. They have a library ecosystem, so basically implementation of the API SDKs for libraries, frameworks, drivers, and more. Sometimes in form of Java agents, so there might be some dragons there. And the cherry on top is OpenTelemetry collector. This is basically what I use, for example, for voltage sampling in tracing. It basically allows me to get data, receive data from different sources and export them to different sources. And the last, I would like to mention events. It's called True Observability or Observability 2.0. I know, buzzwords and so on. But events are basically spans. They are not some magic sauce. They are just the fuel for the columnar storage and query engines that are the superpower for those. The superpower that go through events. They basically, those two things give you ability to slice and dice your data and discover so-called unknown unknowns. And what are unknown unknowns? Things that we don't know that we don't know. So basically, this is from a tool called Honeycomb. And guys from one company decided to migrate from logs to tracing and to Honeycomb. And when they started using that, they found things like this. They found something happening that it would never show up on the P99 metric. You would never find it. And they would find that basically they had a useless index on the database that they dropped, and suddenly those little things disappeared. The inspiration for this kind of tools, because it's a kind of tool, it's not one tool anymore, it's Scuba from Facebook. Basically, that allows the engineers to find problems like why this service has a problem with requests from East Europe and doesn't have a problem with one from the Central Europe and so on. It's called Scuba. It's a link. There is a whole research paper. I will post slides and you can click and read the whole. It's quite interesting. The OG, like the OG was the Scuba in Facebook, but the first generally available for people was Honeycomb.io. They are a SaaS. They are premium. They have a free tier that you can use. I think the second tier that you have to pay is $100 per month, so it's not a lot. And they're a very nice company because they have a blog post called "How to Avoid Paying for Honeycomb," when they basically give you tips how to avoid paying for their own service. But I know that every person that used it and used it basically became some kind of evangelist of them, and they always, when they change jobs, they always try to bring Honeycomb with them. So this is how the UI looks. Example. You have the heat map of the durations, you have the dimensions at the bottom, but this is for comparison only. Because 1 month ago, I discovered this. The project is quite old, but they hit 1.0 early this year. They're very comprehensive observability package because they have eBPF, continuous profiling, and so on. But they do have distributed tracing module that runs on the ClickHouse database, so it's a columnar storage. And it looks quite similar. It's the same, I would say. Oh, sorry? This, different colors, but you get the drift. And I would like to give you a little debugging sessions with Honeycomb. This is a sandbox that they have on their site, so you can go and click there and just view the product. You don't need to have a boring sales call when they will be pitching you how awesome our product are. You can go and test it on your own. Let's say that we are in a new company, we have an onboarding buddy, and our onboarding buddy takes us, "Hey, new guy, come with me. I will show you how we solve production errors." So he logs into this tool, draws a graph. And as you can see, basically the platform is living somewhere into the space and so on. So he says, "Okay, I know that there is some interesting data in that, but I would like to know what's happening here." So he selects this around just the tip of this mountain. Let's see. And then selects investigate with Bubble Up. And says to us, "Oh, Bubble Up will basically split all this data and compare the stuff from the yellow rectangle with the rest of the graph that we can see. So we can quickly find the what is so special about data in the yellow, about the traces in the yellow rectangle." So as you can see, it splits us into two colors. The navy one is baseline, and the yellowish orange one is the selection. Let me zoom on that. What stands out in this one?
One user.
We have a winner. Well, there are a lot of, because I clicked all of them and they always give me the source, but user ID, so that's basically 100%. One user ID, one value of user ID is 100% of selection and only in 30% of the baseline events. So I can click on this little pixel, because it's usually 1 pixel, and just filter to show me the traces that contain this value, this specific user ID value. That gives me this nicely filtered map. I pick a trace from the top, and I get a trace. Something stands out? Or do I need to do some CSI shit on it?
Yeah, like we have one long
Yeah, well, I seen longer. That 30,000 one was long. But yeah, let me zoom in. Now? Yes. Yes, this is as you can see, this is the problem that we got. We are doing the same thing. This is like the default of implementing tracing in your system. You see a lot of stupid requests done multiple times. So I can click on this specific span, the get discounts one, and I will, on the right side, I will see all the metadata from that span, but also the honeycomb would show us the filtered. Oh, this is only the spans from this guy, right? So if we click on this specific graph here, we'll get another filtered stuff. And as we can see, there is a little marker on the top. So we go over it and it says us that someone deployed the checkout service during that time. So to solve the issue, for now, we just have to undeploy it, deploy the previous version. And of course, analyze why someone made such a stupid mistake. Yeah, I think we're done. Thank you very much.
Super, dziękujemy Ci, Michale.